All right, so let's check in on these scores. So our population for today should be all of the AP midterm scores within this set. So the about 60 students that we have data from. Now your sample, we're just going to change that word all to the 5 scores that you were given. So each of you were given 5 midterm scores when you came in the room today. Now the parameter, so this is going to be a measure from the population, and we're not sure what the parameter is yet. So we're going to use the symbol mu to represent the population mean. That's just the true mean, the actual mean from all 60 of these test scores. And we don't have an actual number to fill in that position yet. That is kind of the whole point of what we're looking at today. We're trying to estimate what the actual true mean is by figuring out an interval that we think contains that mean. Now your statistic, you do have a value that you can fill in the space here. So you should go ahead and fill in the number that you calculated from your 5 scores earlier. And because it is a statistic, it's coming from a sample, we can use the X bar symbol to represent what you got for your sample mean. All right, now in part 3, you are going to change your point estimate. So your point estimate is what you got here for your sample mean. I'm actually just going to make a little note of that off to the side here, since we're referring to a point estimate through the rest of today's activity. So you're going to turn it into an interval by adding or subtracting the same number from your point estimate. So you want to account for a little bit of error. And so a little bit above, a little bit below, that number that you add or subtract is actually going to be called the margin of error. And this is really up to you. And actually, I want you to collaborate here with your group on what margin of error you will choose, because you each have a different sample of 5 scores. So I will check in with your group to see how your sample mean compares with everybody else's. And then together, I want you to decide on what your margin of error will be. All right, so this is not necessarily the margin of error that you have to choose. It's just going to depend on what you think it would be with your group, because remember, ultimately, you want to try to capture the true mean, but you want the smallest interval possible that's going to do that. So for example, if I had fed data, let's say that my sample mean was 83.6, I'm talking together with my group, and together we kind of decide that we think that the true mean might be above or below that point estimate by maybe 3 percentage points. I could turn that into an interval by actually adding and subtracting 3. So if I subtract 3, my lower bound would be like 80.6, and then if I add 3, that's going to get me up to 86.6. Now all of our answers here for number 4 are going to be different. So this is just an example. Your interval is going to depend on what you decide to do with your group based on all the samples that you've received. And so once you determine what that interval is, you're going to go ahead and answer question 5. So I want you to answer how confident you feel that your team's interval captures the true mean, and I want you to answer that with a percentage. What percent confident would you be? All right, so let's take a look then at part 6, where we actually had an interval from one of the groups. So we had a different group that got 71 to 79 as their interval. Well, in order to figure out the point estimate, we know that's just going to be at the very center of our interval. So we could think about adding our 2 endpoints, 71 plus 79, and then simply just dividing by 2. To find that exact center value, or you can just think about kind of working inward to get to the center. This point estimate would have been 75. So if we were to think about a little formula for getting point estimate, if we know the interval and we call the first value A and we'll call the second value B, in general, to get our point estimate, we're going to think about doing A plus B and then divide that by 2. All right, then you needed to figure out the margin of error. So there's a couple of ways we can think about this. Surely, if we know that the center of the point estimate is 75, we can just think, well, how far are we going to get to each endpoint? And it seems like it's 4 spaces above and 4 spaces below. Another thing that we can do with the two numbers, what I like to do is think about finding the width of the interval. So what is the total distance from start to finish? So I'm going to do the higher value, 79, subtract the lower value of 71. So that's telling us that the width overall is 8. And then we're going to divide that by 2, just since we have that margin of error happening in both directions. And that's still going to get us to the same answer of 4. And so generally for our margin of error, we can think about doing the second value, b, subtract the first value, a, and divide by 2. Okay. Were there any other groups that had a note card out that haven't brought it up yet? I think I only got 6 back. Anybody still have theirs? I think we have 8 groups. You guys have one name? Okay, because we're about to reveal the true mean score. Okay, so we had 3 groups that actually did capture the true population mean within their interval. So let me tell you what the true mean exam score was for this set of data. It was 85.74. So it looks like Nate's group, Brian's group, Daniel's group, you guys all had a true mean, and you actually had a tie in the width of your interval. All 3 of you had an interval of 6. So you all said plus or minus 3 percentage points.
Yeah, wait.
You guys had it as well?
We had 5.
Oh yeah, I'm sorry. Okay, almost every group captured it. What the 3 groups that I said, sorry, had the smaller interval. So a lot of people had an interval of width 10. And so I was just looking at the ones that had the smaller interval. So almost everyone, actually I think there was only 1 group that was slightly below. So awesome job. So almost everybody captured the true mean. And so here's how we're going to go ahead and answer the second part here. So does your interval support or deny the claim? So almost everybody, the answer would be yes. If not, it would just be because that true value was not actually in the interval that you came up with. So let's go ahead and answer that something like this. So we can say, yes, the true population value is either within my interval, or no, it was not within my interval. All right, so here's the thing about confidence intervals. They simply contain all of the plausible values. So we're kind of trying to figure out what seems to be a believable range, what are believable values that the true population mean could have been. So not that anybody here in the class did this, but by looking at the sample means that we got from our data at the start of class, the means were probably somewhere in the 80s, most of them. So it wouldn't make sense for a confidence interval to be, we think that the mean score was somewhere between like 25 and 35. That wouldn't really be in alignment with what we've actually collected from our sample data. All right, so that is the idea of a confidence interval. Let's go ahead and turn over to the back side. All right, we have a lot of learning targets today. So let's look at the top of our list here. So we wanted to identify an appropriate point estimate, and also calculate the value of a point estimate. All right, so first off, what a point estimate is, it's just a statistic that provides a reasonable guess about the population parameter. And remember that a statistic always comes from a sample. So in our activity for today, we had a sample mean, and we were using that to try to estimate a population mean. You could also do this with proportions. So you could take a sample proportion, which would be a p-hat, and use that to try to estimate a population proportion. All right, and then we talked quite a bit about confidence intervals. So one of our learning targets was to interpret a confidence interval in context, be able to determine the point estimate and margin of error from a confidence interval, and then use a confidence interval to help make a decision about a parameter. So first we have kind of this formula for what creates our confidence interval, and that is that it's a point estimate plus or minus a margin of error. And if we had a specific confidence interval from point A to point B, we saw that we could calculate the point estimate by adding A and B and dividing by 2. So that's an easy way to get the exact center of our interval. And our margin of error, you'll start to see me abbreviate it like this a lot. We're going to take our endpoint minus the starting point to get the width of our interval and divide by 2. All right, and then we have sort of a little sentence frame here that we got a preview of on the first side for how we want to interpret a confidence interval. This is a sentence that we're going to be using a lot throughout Chapter 8. So as we saw before, it's going to start like this. We are blank percent confident. That the interval from A to B and we would just fill in those values with whatever our endpoints are. Captures. You could also say contains, but you'll see me write it as captures. The true parameter. So depending on what we're looking at, it could be captures the true mean or captures the true proportion. So those would be two different types of parameters. Of whatever our context is. So today it was captures the true mean of AP midterm scores. And finally, if you can fit this down there at the very bottom, our last learning target that talked about using a confidence interval to help make a decision. So what we talked about on the front side is just that the confidence interval is going to give us all the plausible values. So when we're trying to make a decision about a claim, we're just going to be looking at seeing, well, does my interval of plausible values, does that support the claim or does it deny the claim? And it's going to depend on our situation. So sometimes yes, sometimes no. It's just going to be sort of a case-by-case basis what kind of decision is made. All right, so we're going to take a look at our check for understanding questions. So it says here that the Pew Research Center and Smithsonian Magazine, they recently quizzed a random sample of 1,006 U.S. adults on their knowledge of science. Now, one of the questions asked, which gas makes up most of the Earth's atmosphere? Hydrogen, nitrogen, carbon dioxide, or oxygen? A 95% confidence interval for the proportion who would correctly answer nitrogen tells us is 0.175 to 0.225. So in other words, about 17.5% to 22.5% is a 95% confidence level. You're going to go ahead and do three things here in this question. So part one, you're going to interpret the confidence interval. In part two, you're going to calculate what was the point estimate and the margin of error. And in part three, if people were to guess one of the four choices completely at random, about 25% should get the answer correct. So we're going to make a decision. So we're going to decide if our interval provides convincing evidence that less than 25% of U.S. adults would answer the question correctly. So let's spend a few minutes working through those three questions. All right, so let's go back together here. So we're going to start to take a look at the first two. So really the first one is just putting our situation into that sentence we have for how to interpret our interval. So it's going to read like this. We are 95% confident that the interval from 0.175 to 0.225 captures the true proportion. So this is a proportion in our problem instead of a mean. It tells us that at the very start. The true proportion of U.S. adults, so there's some more context, who would correctly answer. All right, now our point estimate is just going to be the exact middle value there, so it ends up being 0.20 or 20%. And then our margin of error, when we find out the width of our interval and then divide by 2, we see that our margin of error is 0.025. So when we know how the confidence interval is created, point estimate plus or minus margin of error, it's pretty easy to think about working backwards when you're given an interval to begin with. All right, so let's talk about making this decision here in number 3. So we know that our confidence interval is containing all of the plausible values. All of our plausible values are less than 25%. So when we take a look at the numbers they gave us, like that on the higher end, it's 22.5% of people. So everything is less than 25%. So therefore, that interval does give convincing evidence that it's actually less than 25% of U.S. adults that are going to answer that question correctly. If that 25% fell within our interval, then we could say, no, we don't have convincing evidence that the true proportion is less than 25. Because if 25% was in our interval of plausible values, if it's believable, then that's perfectly okay. We don't have any reason to believe that it wouldn't actually be that number. All right, if you have your Chromebook with you today, I'm going to have you take out your Chromebook, and I'm going to have you actually log on to Schoology. So there is a link to an applet that we're going to spend a little bit of time taking a look at. I put it inside of the Chapter 8 folder, and the link for the applet is actually in tomorrow's section of time. We're actually just going to get a little head start on what we're going to be looking at on block day. This applet is going to help us to start to explore and understand the meaning of what the percentage means. So, like, what's the difference between saying that we're 90% confident that it's contained within a certain interval versus 95% confident versus 99% confident? So we're going to see what's the difference in those percentages. All right, and if you need to share a screen with somebody that you're sitting next to or somebody in your group, that's perfectly okay as well. I don't know if this will work very well on a phone. I think you're going to want the full screen. So if you go ahead and click on the Chapter 8 folder, the link that we're going to be clicking on is applet, so it's right under the 8.1b. Here. And this is what it should look like when we go ahead and click on the applet. So what we're looking at off to the side, so we've got a population distribution, which is like the wider, longer black line. And then in the middle here, we have the sampling distribution. So, yeah. So we saw this back with one of the other applets on the central limit theorem day. It makes sense that the sampling distribution has lower variability than the population, so it's closer together. That peak is a bit higher. And the green line that you see going through the center, this represents the mean. All right, the population mean. So you'll notice that we have a few slider tools off to the side, and we're going to begin by, and it looks like we may just have to make an adjustment on our sample size. We're going to begin by having a 95% confidence level, and we're going to change our sample size down to size 5. I'm going to go ahead and adjust this. Okay, so that's about as low down as it can go. And notice how we have a little change there in our picture when we made our sample size lower. So that's interesting. We have a little bit more variability in that sampling distribution because of the smaller sample size. Okay, so what we're going to do here, when we click sample, it is going to choose an SRS from the population, and it's going to display the resulting 95% confidence interval. So let's go ahead and do that. I'm going to do that on my screen. I'd like you to go ahead and do that on yours. Now, the exact position and location of our interval from screen to screen may slightly be a little different. What we're looking at here are these little orange dots. These each represent one data point from the population. And then we have found the mean, or the point estimate, from this sample. So that is showing up as this dot in the middle. And then the line here is showing us the width of a 95% confidence interval based on what we just got from the sample. So this would be the lower end, this is the higher end. This distance right there, like the halfway distance, that's going to be the margin of error. All right, again, the true population mean is the green vertical line. So we can see here that in our first confidence interval, it did contain the value of the true population mean. All right, we're going to do this again. So actually, we'll go ahead and answer the first question here, number 2. So it says, did the first confidence interval capture the true mean? On mine, it did. If you happen to have one where it did not, that's okay too. Confidence intervals are not perfect. They are not correct 100% of the time, so it's okay if yours did not. In fact, on the applet, it'll show up in red if it did not actually contain the true mean. Okay, so we're going to actually repeat this process 10 times. So we're going to continue hitting sample 9 more times. And we're going to sketch what you see off to the right in this little open space here. And then we're going to answer the question, how many of the intervals capture the true mean? All right, and I'm going to do this on mine as well. Sample, sample, sample. So you can see a little bit of variability in the values that have been chosen. 7, 8, 9, 10. All right, and it'll actually show you off to the side here, like how many you've done. So like I've done a total of 10. Mine happens to hit the true population mean every single time. But again, it's okay if not. But it'll tell you down here below the percent that hits the true population mean. And then this is what we're going to draw off to the side. So if I was doing this here on paper, I would make a little sketch here of the population. We're going to do a little sketch here of the sampling distribution. I would draw that center line, and then you're just going to go ahead and sketch the pattern of your confidence interval, just as you see here. And next to your sketch, if you haven't already recorded this on paper, make sure you also write down how many of those intervals capture the true mean. Did you get all 10 of them? Did you get 9 of them? in the applet to do this, to sample a set of 25. So we're going to sample 25 4 times. So I'm going to go ahead and hit reset. And the question is going to be, all right, how many of the 100 actually captured the true mean? So here's what it would look like on mine. So I'm going to do my first sample of 25. Looks like all 25 of them captured the true mean. I'm going to hit it again, and you'll notice that it's just going to be a running total here at the bottom. So that total there is going to turn into 50. And I'm going to have you do this on your screen as well. Wow, it looks like my next 25 also all captured. There was one that was like a couple that were a little close, where it almost didn't capture it. But so far, all 50 of mine have. I'm going to hit sample 25 again. All right, look, I have a couple red ones off to the side. 2 confidence intervals so far did not capture the true mean. And I'm going to hit sample 25 one more time. In my last set of 25, I just had another red one out here that was really close, but it did not capture the true mean. So out of the 100 that I did, which is going to be different from yours, I ended up getting 97% that capture the true mean. What I'd like you to do when you're done with your 100, so I want you to write down the number that you got, and I want you to turn to your group and tell each other what were everybody's percentages.
98.
Okay, and I want you to raise your hand if your percentage was somewhere close to 95%. It's okay if it was not exactly 95%, but somewhere close, maybe 1 or 2 percentage points above or below. So we have hands everywhere. You can go ahead and put your hands down. So almost everybody in the room had something close to 95%. Mine was 97. That was pretty close. So that's what the percentage means. So a 95% confidence level means that if we were to make 100 confidence levels, we would expect about 95% of them to contain the true population mean. So we're going to end with that. Make sure you bring this same day 2 paper with you back tomorrow. We're going to record all of this in, and we're going to continue where we left off with that applet. We do have to get